to this puzzle session. Here is the problem. Suppose we color the plane with two colors. So the entire plane has been colored with two colors, let's say red and blue. What that means is that every point of the plane has been assigned a color, either red or blue. We want to show that one can find an equilateral triangle, all of whose vertices have the same color. So we need to show that there is some equilateral triangle somewhere such that all the three vertices are either blue or all the three vertices are all red. So very interesting problem. And as usual, you're encouraged to pause the video before we look at the solution that I'm going to discuss. And with that, let us proceed. So we will use a result that we have already proven in another puzzle session. Hopefully I won't forget to put a link here, but let me read it out. The result is, if a line is colored with two colors, then there exist two distinct points A and B on the line, such that A, B and the midpoint of A and B have the same color. So suppose a line has been colored with two colors, say red or blue. Then what we have already shown previously in some puzzle session is that there will exist 2 points A and B such that A, B and the midpoint of A and B all have the same color. And in this diagram I have chosen red just for concreteness. We will use this. Okay, so our plane was assigned colored with two colors. So just pick any line in the plane. And there you use this result to locate 3 points such that this distance is equal to that distance and the 3 points all have the same color. Let's say red for concreteness. And now complete this equilateral triangle that I'm going to show. Yeah, so complete this equilateral triangle. Basically, erect the equilateral triangle whose side length is this, with this being the base. And this line is the line that passes through the midpoints of these two sides. So we make this. And now note that this triangle is also equilateral. It is just a smaller copy of the big triangle. And same is true for this. And now if this point were also colored red, then we would find a red equilateral triangle. So we may assume that that point is blue, or otherwise we will be done. So let's put that there. And by the same reasoning, we may assume that this is also blue, because otherwise we are done. So that is blue. And now, if this were red, then we would have a big equilateral triangle, all of the three vertices of whom would be red. So this also must be blue. Again, otherwise we will be done. Oops, what did I do? Yeah. But now look at this. This is a blue equilateral triangle, meaning all the three vertices of this equilateral triangle are blue and we are done. So we kind of force this equilateral triangle here. We recursively made it. And difficult to explain the core of this reasoning, but it's easy to follow at the very least, I suppose. And yeah, that's the full solution. But here is a variant of the problem, which I leave as an exercise. It is very, very similar to the one that we just discussed. So here we color the plane with two colors. We want to show that there is an isosceles right triangle, not an equilateral triangle, but an isosceles right triangle, all of whose vertices have the same color. So we want to locate something like this. So it's that all the three vertices have the same color. And there are various ways of doing it. You can immediately use the previous proposition to deduce this. There is one way to do it that way. Or you can repeat the reasoning of the previous problem. Anyway, so I want to end this here. As usual, like, comment, share, subscribe, and I will see you next time.